set of limits that we were asked to evaluate, and we didn't have to do an epsilon n proof, but you were asked to show any algebraic steps involved. So I'll be full in gory detail on that first one, and then I'll sort of lighten up on the other ones, but on the exam you would have put in as many details as you needed to convince me of the properties in the background. So for the first one, we have limit 2n minus 5 over 5n plus 3. So algebraically, I'm going to multiply both top and bottom by 1 over n. What are we going to get from that then? Looks like we'll have a limit. 2n times 1 over n would be 2 minus 5 over n over 5 plus 3 over n. Okay. Next, we did prove that limits move nicely through addition, subtraction, multiplication by constants, things like that. So we can say the limit 2 minus 5 times the limit 1 over n over limit 5 plus 3 times the limit of 1 over n. Okay, now we did show that the limit of this and the limit of this are 0. So now you can see what we're left with is the limit of 2, which is just 2, minus 5 times 0, over 5 plus 3 times 0. So of course that's going to end up being 2/5. So the limit laws give us 2/5 as the limit of that front one, of the top one. Now the second one, this is an infinity minus infinity form, right? So it's indeterminate. So the strategy on this particular one, since it involves a radical, might be to multiply by the conjugate. Turns out that's going to work here nicely, but let's give it a shot and we'll see. 4n squared minus 5n plus 2n and 4n squared minus 5n plus 2n. So of course when we distribute here, what are we going to get? We're going to have a limit. In the top it's now a difference of squares, that's why we multiplied by the conjugate. So you get a 4n squared minus 5n subtracted by 2n times 2n, which is 4n squared. And in the denominator we have this radical of 4n squared minus 5n plus 2n. Okay, notice a little bit of convenient cancellation here, and that's really nice. And now it's essentially rational, almost rational. We still have this radical down here, but again, like the first one, I'm going to multiply through by 1 over n, which is the largest exponent, the largest power in the denominator. Now you might notice there's an n squared over here, but notice it's under a radical. So really when I distribute, this one's fine, that's just going to be a 1 over n. Technically when I distribute on that one, I'm going to be multiplying by a 1 over a radical of n squared, because that's what's going to come into the radical really nicely. Okay, so what do we end up getting? Looks like the limit of, see, on the top we would just have a negative 5. On the bottom, let's do this one over here first. This would definitely just be a plus 2. And then what is really going on under that radical now is that when we bring in the n squared, the 4n squared over the n squared is just going to be a 4 minus, and then the 5n over the n squared is going to end up being a 5 over n. And notice yet again, this part right here is again going to go towards 0. So the net result when we go through and do all of our limit now is going to be negative 5 on the top. On the bottom you'll have a square root of 4 plus 2, and of course square root of 4 is 2, so the final answer here is negative 5/4. Okay, that's those two. This was a 4-part problem. The other 2 parts of the problem were these two, and we did have a rule inside of the book that said, if you recall, we proved this in class, that the limit of a to the n equals 0 if absolute value of a happens to be less than 1. So in this case, our rule actually just says that this limit is definitely 0, because notice the absolute value of negative 3/4 is 3/4, which is clearly less than 1. So this one's limit is just 0. The last one is actually divergent. It oscillates, plus it goes off towards infinity, and I think that I would have accepted an argument something along the lines of just writing out a few terms perhaps, or even just observation. Negative 4/3 is the first term, then you get 16/9, and then you get, what, negative 64 over 27, etc., etc. And you can see that the numbers are getting larger and larger, but they're not settling down towards something, and it's oscillating. It's really clear it's going plus minus plus minus. So here you would be able to say that this limit does not exist, and just giving some kind of argument about why you think it doesn't exist.